Hey Condors, it's your boy Mr. Roberts coming at you live with a little bit of social distancing science. Hey, before we get started with our agenda, don't forget to subscribe. And once you've subscribed, hit that bell so you don't miss any future episodes. Let's see what we're doing today. Okay, we're going to do a science probe about objects in our solar system. We're going to encounter the phenomena of the solar system. We're going to read about what objects make up the solar system. We're going to do an investigation about comparing the view. And then we're going to read about how do astronomers observe the solar systum. So let's go ahead, get logged into McGraw Hill, and let's get started. Here's our probe. A system consists of parts that make up a whole. What are the different parts that make up our solar system? Identify each of the objects you think are part of our solar system. So, out of these, do you think planets, distant stars, comets, galaxies, the sun, constellations, moons, black holes, nearby stars other than the sun, asteroids, human-made satellites, or the universe are part of our solar system? And then describe how you determine whether an object is part of our solar system or not. Next, we're going to encounter the phenomena. So how do objects in the solar system compare? Let's check out this video and learn a little more.
Have you ever been on a road trip and asked the question, "Are we there yet?" If the response to your question was, "Only a few more astronomical units," the following questions might come to mind. What are astronomical units? Does that mean we are close? An astronomical unit, or AU, is equivalent to the average distance between the Earth and the Sun, 149,600,000 kilometers. Astronomical units are used to measure distances of the planets from the Sun in our solar system. Distances between the planets and the Sun are so large it is easier to express these distances using astronomical units rather than kilometers. Planets closer to the Sun than Earth, such as Venus and Mercury, will be less than 1 AU in distance, while planets further from the Sun than Earth will measure at more than 1 AU in distance. Distances in space are so large that it would take a very long time to reach even the closest planets. Let's use Mars as an example. The average distance between Earth and Mars is 0.52 astronomical units, or 78,320 kilometers. Given the average distance between Earth and Mars, and traveling at a basic highway speed of 110 kilometers per hour, you would arrive at Mars in approximately 81 years. Traveling by spacecraft might be a better option. A one-way trip to Mars by spacecraft would reduce your arrival time to approximately 9 months.
Still not very close. The video shows how scientists organize objects in our solar system using distances. Think of other characteristics that you could use to organize the objects in our solar system. Create a graphic organizer below categorizing solar system objects below using one of those characteristics. Okay, let's read about what objects make up the solar system. Recall that gas, dust, and stars make up galaxies. Stars are made up of gases undergoing fusion at the core. What's in a solar system? A solar system contains at least one star and all the objects that orbit around that star. This includes planets, moons, comets, asteroids, and meteoroids. Okay, we've got a quick little investigation called Compare the View. Now, ancient astronomers looked at the night sky and they saw many stars but only 5 planets: Mercury, Venus, Mars, Jupiter, and Saturn. The invention of the telescope in the 1600s led to the discovery of additional planets and many other space objects. Telescopes enable astronomers to observe many more stars than they could with their eyes alone. Telescopes are designed to collect a certain type of electromagnetic wave. Some telescopes detect visible light and others detect radio waves and microwaves. Astronomers use many kinds of telescopes to study the energy emitted by stars and other objects in space. Let's look at the differences in telescope technology. So look at these images below. These images were taken from a telescope you might use in your backyard. Based on these photos, describe the differences between the two planets. Now look at these. These images are the same planets, but they were taken from a space-based telescope. Now describe the differences between the two planets. You know, in addition to telescopes, space agencies like NASA have sent probes and other exploratory spacecraft into space. For example, the New Horizon mission explored the Pluto system within our solar system and will explore objects on the outer edge of the solar system in the Kuiper Belt. Other spacecraft, like the International Space Station, or ISS, houses rotating shifts of astronauts for research purposes. The experiments conducted on board the ISS will aid future crewed space flights. The space program requires the development of materials that can withstand the extreme temperatures and pressures of space. Much of this new technology has also been adapted for use in materials on Earth. Some of the examples of everyday materials that are developed as the result of the space program are satellite television, medical imaging, and home insulation. Okay, that's all for today. Have a great day. I will see you all later.